hope you all are doing good. I am Anjana from Learnohub, the free learning platform where you can study math, science and SST absolutely free at learnohub.com. In today's class, we are going to discuss ICSE Class 9 Physics Chapter 7, Reflection of Light. We'll be discussing about the reflection of light and the image formation by plane mirror. We'll also be solving questions from exercise 7A. Are you ready for the session? Let's begin. Reflection. What happens when you stand in front of a mirror? When you stand, every morning you stand in front of a mirror, right? So what is happening? You stand in front of a mirror to see yourself. That is, an image of yourself is obtained in the mirror. Yes, when you lift your hand, the image will also be lifting its hand. Yes, when you bend down, the image will also be bending down. We all know this, right? What happens? You are able to see sun inside water. You are able to see moon inside water. Yes, in a pond, you will be able to see them. Yes, why is it happening? This is all because of reflection. So, when you have a surface, okay, when light rays from an object falls on a surface. So, if this is a surface and the light rays from an object falls on a surface, what happens is this surface will reflect the light rays. Okay, when this reflected light rays enters our eye, we are able to see objects. Okay, so normally there are luminous objects and non-luminous objects. Luminous objects are bodies which can emit their own light. For example, sun is a luminous object. Yes, so sun is able to emit its own light. So, we will be able to see sun. But what about the case of other object? In other object, that is non-luminous object, what is happening is light rays will strike them and the reflected rays which reaches our eyes, okay, helps us to see the object. So, got an idea about reflection. What is reflection? So, normally when light rays falls, in case of different surfaces, reflection will be different. Some light rays sometimes get absorbed by the surface. Only the remaining light rays will be reflected. So, when you try to get the image of an object, okay, you place a plane mirror, the mirror that we are using, plane mirror, and also a water surface, okay, a pond or something. In which case do you get a clear image? A clear image is obtained in the case of plane mirror. Why this is happening? So, there is a difference. In case of water surface, what happens is the water is absorbing some light rays. Okay, only the remaining will get reflected. So, this is what is happening. So, the best thing that can be used to obtain a proper reflection, a proper image is a plane mirror. So, plane mirrors we normally represent it by a straight line shading at its backside. Okay, a plane mirror, it is usually made up of glass of very small thickness in millimeters, 1 millimeter thickness glass is used. Okay, the opposite side, it is silvered. Yes, so this is a case of a plane mirror. So, understood what is reflection? Reflection is different in case of different surfaces. Regular reflection and irregular reflection are the two kinds of reflection. Now, what they are? Okay, so here you can see this is a smooth surface and here we have a rough surface. Smooth surface, example, a mirror. Okay, so the light rays, let us consider some parallel rays of light falls on a smooth surface. So, what is happening? You can see this is an incident light. Okay, here we have the incident light. After reflection, what is happening? You can see how the light moves, light rays move. You can see that here the incident light rays are parallel to each other. The reflected light rays are also parallel to each other. They are moving in the same direction. Okay, they are moving in the same direction. So, this is a case of a smooth surface where the reflection that is happening is a regular reflection. This is regular. Yes, there is equal distance between the rays. Now, when you take the case of a rough surface, example for rough surface is the wall of a room, the floor, or a paper in a book. All these appear to be smooth, but they are not actually smooth. Okay, they will be uneven surface. For example, the surface will be in this way, some unevenness will be there. So, what happens when light rays falls on these surface? So, this is the first ray. Okay, first ray is incident on this rough surface. What is happening? You can see the reflected ray. This is the reflected ray. This is how the reflection is happening. Next ray is parallel to the first ray. This is the first ray, this is the second ray. Okay, so you can see that the second ray is parallel to the first ray. What about the reflected ray? So here it is striking. Okay, on the rough surface at this point, the ray is striking. What is happening then? It is getting reflected in a different direction. Now just compare. This is the reflected ray of first ray. This is the reflected ray of second ray. Are they parallel? No, they are not parallel. Okay. So now this is your third ray. Where do we see the reflected ray? In this direction is the reflected ray. Okay. This is your fourth ray. Reflected ray is in this direction. Okay, so you can see that when the light is incident, parallel beam of light is incident on a rough surface, what is happening? The reflected rays are in different directions. Okay, so how do we see objects? Objects, that is, we are able to see objects because of this type of reflection. Okay, what is happening to the light ray? The light ray inside a room, if you have a bulb or a tube, light rays from there will go strike the walls. Okay, walls you can see they are rough surfaces. So what happens? They will be reflected in different directions. So this type of reflection we call irregular reflection or diffuse reflection. Okay, this diffuse light is helping us to see objects clearly. Okay, light gets spreads in different direction, but that is not the case of a smooth surface. In smooth surface, you can see the incident ray and the reflected ray properly, and also when you take three light rays which are parallel to each other, the reflected rays will also be parallel to each other. Okay, so regular reflection occurs when a beam of light falls on a smooth and polished surface such as a plane mirror. And irregular reflection occurs when a beam of light falls on a rough or ordinary surface such as wall of a room, the page of a book, etc. Clear? Now let us discuss in detail about the reflection at a plane mirror. We have to memorize some important terms here. Okay, so here you can see this is a plane mirror. Consider this is a plane mirror. Normally we represent a mirror in this way, that is a straight line and give a shading. Okay, this is how we represent a plane mirror. Okay, so let us call this M dash. M dash is the plane mirror. Okay, you can see a ray of light that is falling on the plane of, okay, there is a light ray which is incident on the plane mirror. So this ray we call the incident ray. So here this is the incident ray. Let us call it AO. What is O then? O is a point at which the ray of light is incident on the plane mirror. This point we call the point of incident. So two terms we got. First one is the incident ray. Second one is the point of incidence. Okay, after the light ray is incident, what happens? It will get reflected. Then there will be a reflected ray. The ray which comes out of the plane mirror, okay, is called the reflected ray. Okay, OB. Let OB be the reflected ray. Okay, now this we can name it as N. So ON is a straight line which is perpendicular to the plane mirror. Okay, so if plane mirror is kept in this way, there will be a perpendicular drawn. What is perpendicular? Which makes an angle 90 degree with the surface is called perpendicular or normal. Okay, so here you can see a normal. This perpendicular line we call the normal. Normal is ON. Okay, now you can see an angle is formed between the incident ray and the normal. This angle we call the angle of incidence. Okay, this angle which the incident ray makes with the normal is called the angle of incidence, and the angle made by the reflected ray with the normal is called angle of reflection. Okay, so here what is the angle of incidence? Angle of incidence is represented by angle I. Okay, an angle of reflection is represented by angle R. Sometimes just I and R is used to represent angle of incidence and angle of reflection. Okay, so here this is angle of incidence. Okay, here the angle of incidence will be equal to angle AON. What is the angle of reflection? Angle of reflection is equal to angle BON. BON is the angle of reflection. Okay. Next term is plane of incident. That is a plane which contains the normal and the incident ray is called the plane of incidence. So this plane is the plane of incidence. Okay, and the plane of reflection is the plane which contains normal and the reflected ray. Plane of reflection. So here we have got the surface is MOM dash. Then the incident ray is AO. Reflected ray is BO. Normal is ON. Okay, then angle of incidence is AON, angle AON, and angle of reflection is angle BON. So these are the important terms. So reflection obeys very important two laws. These are called the laws of reflection. If reflection is happening, only if reflection happens, only if these two laws are obeyed. So first law is the angle of incidence I is equal to the angle of reflection R. So here you know what is angle of incidence and what is angle of reflection. The angle made between the incident ray and normal is called the angle of incidence, and the angle made between the reflected ray and normal is called the angle of reflection. Okay, so here incident angle is I and reflected angle is IR. Okay, so AO is the incident ray, ON is the normal. So the angle made between them, that is angle AON is the incidence angle of incidence, and the angle of reflection is angle BON. So according to the first law, angle AON is equal to angle BON, or I is equal to R. Angle of incidence is equal to angle of reflection. If angle of incidence is 30 degree, what is the angle of reflection then? Angle of reflection will also be equal to 30 degree. Okay, if angle of incidence is equal to 45 degree, angle of reflection will also be equal to 45 degree. If angle of incidence is 60 degree, then angle of reflection will also be equal to 60 degree. Okay, both will be the same. Next is the second law is the incident ray, the reflected ray and the normal at the point of incidence lie in the same plane. Okay, so here you can see this is a plane mirror. Okay, so here you can see a plane. A ray is incident. Okay, this ray is incident. Here you have the reflected ray. This is a point of incident and this is the normal. So all of these are lying on the same plane. Okay, one plane is the mirror. Okay, so this mirror will be always perpendicular to the plane on which the incident ray, normal and reflected ray lies. Okay, it will be perpendicular. And you can see that incident ray, normal and reflected ray at the point of incident, all of these are on the same plane. Yes, they are on the same plane. If this is a plane mirror, this is the plane mirror. Here you have the normal, incident ray, reflected ray, and this is the normal, this is the point of incident. You can see that I can represent all of them on the same plane and the mirror will be in this way, that is it will be perpendicular to it. Okay, since I am able to represent it all on the same plane, we can say that incident ray, normal and the reflected ray, all of them lie on the same plane. So these are the two laws of reflection. Next, the reflection of a ray of light normally incident on a plane mirror. So we call this the normal incidence. Okay, for a ray incident normally on a plane mirror, what will be the angle? This is my question. What is incident angle? Angle of incidence I is equal to the angle which is made between the incident ray and the normal. Okay, so here what is given? Normal incidence is given, that is incident ray is perpendicular to the plane mirror. Okay, which means the incident ray and the normal will coincide. Okay, they will coincide. They are the same line. Okay. Here for this mirror, this is the normal. Here we have the mirror M dash and this straight line is the normal which is perpendicular to the mirror M dash. Okay, and you can see that the incident ray is passing along the normal. So here we have the normal and the incident ray is passing along the normal. Okay, so what is the angle made between the incident ray and normal? There is no angle, which means the angle of incidence is equal to 0. 0 degrees is the angle of incident. Then what will be the angle of reflection? Angle of reflection R will also be equal to 0 degree. Why? Because we have discussed the laws of reflection. Yes, the first law states that the angle of incidence and the angle of reflection are always equal. So, incident angle is 0 degree, therefore reflected angle is also 0 degree for normal incidence. Then you will be able to see that the reflected ray will also be along the normal. Okay, incident ray, normal and reflected ray will be the same straight line, will be on the same straight line. Just the difference is incident ray is in this direction and reflected ray in the opposite direction. Which means it gets reflected in such a way that, okay, in such a way that the reflected ray will be along the incident ray itself. Okay, that is the incident path is being retraced by the reflected ray. Clear? So this is a case of normal incidence. Only in the case of normal incidence where the angle of incidence and the angle of reflection is 0 degree. In that case, incident ray's direction, okay, the path of incident ray is followed by the reflected ray but in the opposite direction. Experimental verifications of laws of reflection. So we have studied the laws of reflection. Now we are going to verify these laws with an experiment. You can perform this experiment and try. So here what you need is you need a plain mirror, then you need a white sheet of paper that is fixed on a board. Okay. On this white sheet of paper, draw a straight line, name it as M dash. Okay. Almost in the middle, draw a straight line which is perpendicular to M dash. Okay. It is perpendicular to M dash. This line is the normal. Now, what you are going to do is, you will be measuring an angle that is less than 90 degree, which is the angle of incidence. Okay, it should be less than 90 degree. Okay, measure any angle. Let I can be equal to 1, 2, 3, 4. Let's say we will be taking angles 30 degree, 45 degree, 60 degree, 70 degree. Any angle which is less than 90 degree you can take. Okay. So first what you are going to do is measure 30 degree. What is angle of incidence? The angle between the normal and the incident ray. So measure 30 degree. Keep the protractor here and measure 30 degree from here. Okay. Mark a point. Draw a line which touches this point and this 30 degree point. Okay. So this angle is 30 degree. Let's mark this O. AO. Okay. Now, you know small pins, colored pins will be available. Okay. Take 2 pins. Okay. Fix the first pin here at any point and the second pin at another point. Let us name it as P and Q. Only thing is that the distance between these points should be at least 5 cm. Okay. Fixing the points here. Next, what you are going to do is, you are going to check from here where the image is formed. So here, for that what you have to do, you have to fix a mirror. Okay, so the mirror is represented in this way. This is the silver colored portion. So there will be a glass which is in the front and the back side will be silver. So this silver colored portion will be touching the line M dash. So you are keeping a plane mirror here. Okay, when the plane mirror is kept, what happens? In the plane mirror, you will be able to see the reflection. Okay, so when I stand in front of a plane mirror, what is happening? My reflected image is formed. Where is it formed? It is formed behind the mirror. So behind the mirror, the image of P and Q will be available. Yes, image of P and Q will be available. Okay, so can you mark the points here? No, because it is behind the mirror. Okay, so somewhere here and here, you will be able to see the images, which is P dash, Q dash. Okay, now you will be looking from here. Your eyes will be here, you will be looking at the images. So, approximately in the straight line, you will be able to see the image. Okay, so along the straight line, put another 2 pins. Okay, such that when you check, you will be able to see P dash, Q dash and O, all these are along the straight line. Okay, so at that points on that line, put 2 other pins. Okay, let's say R and S are the pins which are put. Okay, now you can remove all these and join these points. That is, we have put the pins in such a way that we feel Q dash, P dash, O, R and S are along the same straight line. Okay, now what you have to do is, you will have to join these points, that is O, R, S. Okay, draw a straight line which is passing through S, R and O. Okay, so here we have measured the angle is 30 degree. Okay, now what you have to do is, you use a protractor. Okay, keep the protractor over here. measure this angle, measure this angle. So you will be able to see that this angle will also be equal to 30 degree. Okay, so angle of reflection will also be equal to 30 degree. Now repeat the experiment, that is, first measure 45 degree, draw a straight line, keep two pins P and Q at points P and Q such that they are at a different distance of 5 centimeter. Okay, after that, that is after proper measurement, we have measured 45 degree and place the pins. Find where this reflected ray is. Okay, that is reflection you will be able to see. When you check from one side, you can feel that they are on the same straight line. Okay, they are coincide. You will be feeling that. Put the two pins over there. Okay, draw the straight line. Repeat it with 45 degree, you will be getting angle of reflection 45 degree. 60 degree, you will be getting 60 degree. 70 degree, you will be getting 70 degree. What does it verify? This verifies the first law of reflection, which is angle of incidence is equal to angle of reflection. Okay, angle of incidence and angle of reflection are same. Now to verify the second law of reflection. So here you can see that, okay, you are able to see that the tip of the pins P, Q, R and S are on the same sheet of paper. Okay, so here we have the sheet of paper and you can see the points, that the edges, bottom part, they are on the same sheet of paper. What does it implies? The incident ray. Okay, incident ray is where the points, that is the edges of the pins are touching. Okay, reflected ray, pins are touching, that is the pins edges are touching the reflected ray. Normal we have drawn. All these are on the same sheet of paper. We are able to draw the incident ray, the reflected ray OB and the normal ON on the same sheet of paper. Okay. Point O is also marked on the same sheet of paper. So incident ray, reflected ray, normal at the point of incidence all lie on the same plane. Okay. This verifies the second law of reflection. So first law and second law verify. This is an experimental verification of laws of reflection. You can just perform this experiment. Formation of image by reflection. Types of images. So here first you need to understand what is image formation. If I am standing in front of a mirror, what is happening? I am able to see myself there. Okay, that which is formed on behind the mirror we call the image. Okay, it is not always necessary that the image formed will be behind the mirror. So here we will be discussing about two types of images. First is a real image and virtual image. Real means what? Actually the image is formed. We will be able to obtain the image. Okay, virtual image means it is just a feeling. Okay, it's just a feeling that the image is formed. It doesn't really exist. Okay, so let's take these two cases. So here you can see that a candle is there. This is a plane mirror. Behind the plane mirror, we are able to see the candle. Okay. So here, this is the object. And this is the image. Okay. So here, if you keep a white sheet of paper, can you obtain this image? Okay. So we are able to touch the object. Okay. Can we touch the image? No, right? We can only take our fingers till the plane mirror. Okay, we can touch the plane mirror, not beyond that, because the image here formed is beyond the plane mirror, behind the plane mirror. Okay, so this is a virtual image. It is just a feeling. The image really doesn't exist. Okay, it doesn't really exist. It is just a feeling that it exists. Okay, now you can see in this case, this is how the object is. The same way the image is also formed. Now take the next case. Okay, here you have the candle, here you have the mirror and here you have the image. So a white sheet of paper or a cardboard. If something is kept, you are able to get the image on it. Okay, it is not formed behind the mirror. It is formed in front of the mirror itself. So here you can see the object is in front of the mirror and the image formed is also in front of the mirror. Okay, candle is used, here the image is formed. Okay, so in this case, a mirror used is not a plane mirror. Okay, so we'll be discussing in detail about spherical mirrors. Okay, where you will understand these type of a mirror, in which after reflection the image is formed, but the image formed is in front of the mirror itself. That is, object and the image are on the same side. Here in the case of plane mirror, object, if it is in the front of the mirror, where the image is formed behind the mirror. Okay, so that difference exists. Okay, so in this case, this is the object and this is the image. One more difference exists. Okay, what is it? Here in this case, this is how the object is. Okay, so object is a candle. This is how the object is. And you are able to see the image is also in the same way. Okay, same thing, same size. Okay, this type of image we call erect images. Erect images. Okay, so this is a virtual image and this is also an erect image. Okay, this is of the same type. Now take this case. Here you can see this is how the candle light is. Okay, the flame is in this way. In this case, in the image, it is in the opposite way. Now, if the candle is like this, upright, okay, you will get an inverted image. This is how the image will be. Image which is formed on the same side. Okay, this type of image is called an inverted image. Okay, so virtual image, real image, erect image, inverted image. Okay, so what are they? Real image, the image which can be obtained on a screen is called real images. So keeping a white cardboard or a white sheet of paper, you can get the image. Okay, you can touch the image. Okay, here can you touch the image? No, right? So image which cannot be obtained on a screen is called the virtual image. You cannot place a screen behind the mirror. Is it possible? No, right? Only in front of a mirror you can do that. So this type of image which is just a feeling is called a virtual image. Okay. So real images are inverted, virtual images are erect. Okay. Distinction between a real and a virtual image. Real image is formed due to the actual interaction of the reflected rays. So we know when you keep a mirror, incident ray, there will be incident rays, it gets reflected. These reflected rays interact to form the real image and this real image can be obtained properly on a screen. What about virtual image? Here proper interaction is not happening. What is happening? We have taken the first case, that is we have taken an experiment. We have a mirror, okay, which is fixed on a plain paper perpendicularly. You will draw a normal. This is your incident ray. On the incident ray, you are putting two pins P and Q. Where is the image obtained? Image will be obtained here. Okay, P dash, Q dash. So we are able to obtain the reflected ray only after extending this line. Yes, so here we are feeling the image will be. Okay, image is here. Connecting that, you are drawing a straight line. Okay, so a virtual image is formed when the reflected rays appear to meet when produced backward. So these reflected rays obtained, that is, it is produced backward. Okay, now the second one, a real image can be obtained on a screen. You can keep a screen, real image is obtained. We have seen the candle. Okay. Now, a virtual image, it is just a feeling. It cannot be obtained on the screen. This is a second point. Next, the third point, a real image is inverted with respect to the object. How do inverted image form? If this is the object, let us say we have an apple. Okay. So, this is an apple. How will the image look? It will be inverted. Okay, this is how the image will be looking. Okay, a virtual image is erect with respect to the object. So, if the apple, this is the apple, okay, similarly, you will be having a virtual image also. Same thing. The image of a distant object formed by a concave mirror. So, we will be discussing in detail about the spherical mirrors, two types of spherical mirrors. So, the image of a distant object which is formed by a concave mirror is an example of real image and it can be obtained on a screen. The image formed will be an inverted image. Okay. The image of an object formed by a plane mirror or by a convex mirror. Convex mirror is also a type of spherical mirror. To get a virtual image, just imagine you standing in front of a normal plane mirror. Daily you will be standing in front of a normal plane mirror. You are able to see your image, but are you able to touch it? No, right? So, this is an example of a virtual image. So, these are the four important differences between a real image and a virtual image. Image of a point object formed by a plane mirror. Consider a plane mirror MM dash. MM dash. Okay. So, here we are considering an object O, which is a point object. So, we know that from the object, light rays will be traveling to all directions. Okay, now consider only two light rays. Okay, so first light ray is incident at a point A. Okay, at a point A. And the second light ray is incident at a point B. Okay, perpendicular to this, we can draw normals. So this is your first normal and this is your second normal, A, N, B, N dash. Okay, so what happens after reflection? After reflection, so if you are checking from here, you will be able to see the image. Okay, image will be formed behind the mirror. Okay, so this is the mirror opposite side, that is the silver colored part. Okay, now this is the incident rays, reflected rays. This will be the first reflected ray, let's say AC, and this is the second reflected ray, AD. Okay, AC and AD are the reflected rays. What happens is, if you extend these, okay, AC I am extending and BD I am extending. Okay, so you will be able to see that they will be meeting at a point. This point is I. And here, this is a point where the virtual image of the object is obtained. So when you are looking from here, you will be able to see that the image is formed. Where is the image formed? Image is formed behind the mirror. You won't be able to obtain it on a screen. You won't be able to touch it. Okay, the image is formed, a virtual erect image is formed behind the mirror. This is a case of a plane mirror. Okay, and the rays of light appears to come from the point I. This point I, it actually don't exist because the image formed is a virtual image. Okay, so when you check from here, you will be able to see that the light rays are coming from I. And I is where the image is formed. I is the image formed. Understood? This is a case in which we can find the image of a point object that is formed by a plane mirror. Understood? Image of an extended object formed by a plane mirror. What is an extended object? So, point object means from only one point we have the light rays in different directions. But in case of an extended object, if you have a candle, okay, so light rays from here, here, from every point there will be light ray. These light rays will be traveling from a single point. The light rays will be traveling in different directions. Okay, so first consider a plane mirror. So this is a plane mirror. Okay, here we'll be considering an object AB. This is an extended object AB. So we'll be considering light rays, 2 light rays each from the starting point and ending point. That is the 2 edges. Okay, from A we consider the first light ray to here. Okay, let's mark this as P, AP. Okay, next light ray from A, let's say it is striking here, Q. There will be many other light rays as well. Okay, similarly from B, there will be light ray, first light ray, BR, second light ray, BS. Okay, these are the incident rays on the mirror. Now what happens? Reflection takes place. Okay, reflection occurs. So this is the first reflected ray, P dash, Q dash is the second reflected ray. Okay, R dash is the third reflected ray, S dash is the fourth reflected ray. Okay, now we are going to extend them backwards. Okay, so these two first will be extending backwards. They will be meeting at a point. So this is the point which I will name it as A dash. Okay. Similarly, R dash on extending backward. S dash on extending backward. They will be meeting at a point. So this is a point. Okay. Which I will be naming it as B dash. Okay. So A dash and B dash when joined, you will be getting. So this is the object. AB is the object. A dash, B dash is its image. So how was the image obtained? The reflected rays. Once you get the reflected rays, you are extending it backward. On extending it backward, the rays from the same point, they will coincide. Okay, those points are considered and joined. Okay, so for AB, its image is obtained, I dash, B dash. Now you are able to see that here the distance, this is the normal distance of A from A dash. Okay. So when you consider, let's say this distance is 2 centimeter, then this distance will also be 2 centimeter. Okay. So object's first edge is considered, its distance from the mirror is 2 centimeter, and the image's first edge is considered, its distance from the mirror will be 2 centimeter. Okay. Now, if this is this point, another point we are considering, if this point is at a distance of 3 centimeter, then this we are drawing a normal, okay, straight line. Okay. So, this point, here this point will also be at 3 centimeter from the mirror. Okay. So, if B is at a distance of 5 centimeter from the mirror, B dash will also be at a distance of 5 centimeter from the mirror. This distance is a perpendicular distance. Perpendicular distance of each points of the image from the mirror will be equal to the corresponding points when considered. The perpendicular distance of the corresponding point considered its distance from the mirror. So, this is a case of an image that is formed by an extended object. In a case of a plane mirror, the image that is formed, it will be a virtual image, it will be an erect image. Okay, position of image. Where is the image formed? For that, first consider a mirror M dash. Okay, so I am drawing a normal to it. Okay, we will consider two rays of light. First ray of light is perpendicular to the mirror. Okay. So, we will name it as OF. OF is the ray of light which is incident perpendicular to the mirror. This is the incident ray. What happens after reflection? When a ray is incident, making an angle I equal to 0 degree. So, here you can see the incident ray and normal are parallel to each other, which means angle is equal to 0 degree. Then the reflected angle will also be 0 degree, which means it will retrace the path of the incident ray. Okay, so this is the path of the reflected ray. Now, the second we are going to draw another ray of light OA, which is incident on the mirror M dash. Okay, at this point A, and this is your normal. Okay, after reflection you will be having reflected ray. This is your reflected ray. Let us mark the reflected ray as AC. So, here you have the angle of incidence, here you have the angle of reflection, they will be equal. Okay, now what we are going to do is, we are going to extend both the reflected rays backward. Okay, so first reflected ray I am extending it backward. Similarly, second reflected ray also I am extending backward. Okay, I am getting a point here which I am naming as I. So, O is the object and I is the image. The virtual image of the object is formed at I. Okay. Now, we are going to show that the perpendicular distance of from the object to the mirror is equal to the perpendicular distance of the image from the mirror. We are going to prove it. That is, OF and IF are equal. So, OF is the distance of the object, the perpendicular distance of the object from the mirror, and IF is the perpendicular distance of the image from the mirror. Okay. To prove OF is equal to IF. Okay. So, let's start the proof. Here, you can see that angle of incidence is always equal to angle of reflection. What is the reason? This is the first law of reflection. Okay. Which means angle OAN. Angle OAN is equal to angle CAN. CAN. This is the reason. Okay. Next, you can see that AN and OF, they are parallel to each other. OI is a straight line. AN is a line. Okay, they are parallel to each other. We know the properties of parallel lines. So, when you have a parallel lines, a pair of parallel lines, when you draw a transversal, a line which is cutting the lines, the parallel lines, you can see that this angle and this angle are equal. They are corresponding angles. Okay. Similarly, this angle will be equal to this angle. What is it? Alternate exterior angle. and this angle will be equal to this angle. They are alternate interior angles. So these are the properties of the angles formed in parallel lines. Okay, so here you are able to see this is one line, this is one line. They are parallel to each other. You can see OA is a transversal. Okay, OA is a transversal which is cutting, which means this angle I and this angle should be equal. Yes, what is the reason? Alternate interior angles. So, angle FOA is equal to angle OAN. Reason? Alternate interior angles. Alternate interior angles. Okay. Next, this is a straight line. This is a straight line. They are parallel lines. You can take this as a transversal. CI is a transversal. Okay, which means this angle and this angle will be equal. They are corresponding angles. Okay, they are corresponding angles. Therefore, angle CAN is equal to angle FIA. FIA. Reason? Corresponding angles. Corresponding angles. Okay. So already we have OAN and CAN are equal. Okay. OAN and CAN are equal. If OAN is equal to CAN and OAN is equal to FOA, then we can say that angle FOA. Okay. FOA will be equal to CAN. CAN. Okay. Because here when you consider the left side of this part and right side of this part are equal. So if you interchange, you can say that the left hand side both are the same. So the right hand side should be same. So FOA will be equal to angle CAN. So we have got that angle CAN is equal to angle FIA by corresponding angles. Okay. So CAN, in place of CAN I can write FIA. So FOA is equal to angle FIA. Okay. So this is the first one. Next, you can see this angle and this angle are equal. Both of them are 90 degrees. Angle OFA is equal to angle IFA. They are 90 degrees. And you can see that FA is a common side. FA, common side. So what can you conclude from this? By angle side congruence rule, AAS congruence rule, you can say that triangle OFA is congruent to triangle IFA. Okay, congruency rule is AAS congruency rule. So when you have congruent triangles, you can say that this angle and this angle already they are equal. These two angles are 90 degree and these two angles will be equal. Similarly, what about sides? This side will be equal to this side. These sides are the common side and these two sides are equal, which means OF and IF are equal. OF is equal to IF. So this is what we had to prove. OF is equal to IF, which means the perpendicular distance of the object from the mirror is equal to the perpendicular distance of the image from the mirror. Okay, the image I is as far behind the mirror as the object O is in front of it. That is, the perpendicular distance of image from the mirror is equal to the perpendicular distance of the object from the mirror. Okay, got it? Lateral inversion. So in front of a plane mirror, when you stand, you will be feeling that the left will be appearing as right and right will be appearing as left. For example, okay, so you are standing in front of a plane mirror. Here you have a plane mirror. I am standing here. Okay, I am lifting my right hand. Okay, so if your friend is standing in front of you, okay, two cases you have to imagine. You and your friend are standing opposite to each other. Okay, so both of you are lifting your right hand, which means you will be able to see that from here it is this hand that you are raising. From the opposite, that is your friend who is standing in front of you will be lifting in such a way that it is this hand. Okay, so the right hand of his will be lifted. This is how it will be like. So both of you are standing opposite to each other. Okay, now consider your image. That is, you are standing in front of a plain mirror. You will be able to see the image of yourself. Okay, so when you lift your right hand from here, what it appears is, in the mirror, it will be like, this is how it is lifted. So you can just try this. Lifting your right hand, you will be feeling that the image formed. Your image will be lifting as left hand. Okay, so why is this difference happening? This is because of lateral inversion. The plane mirror is producing an image that is laterally inverted. Left appears right and right appears left. So here you can see, okay, if you are having a letter D, okay, letter D is your object. So what has happened? When the image was formed, it is not that the letter D is the object and this is how the image is. Is it happening? No, right? What has happened? Left and right has changed. Okay, so this is the left side, this is the right side. So here what has happened? Right side, that is the bent portion, has come to the left. Okay, the bent portion has come to the left. And the straight part, which is the left side, has come to the right. So this difference has happened. Okay, this is because of lateral inversion. Okay, interchange of the left and right in the image of an object is called lateral inversion. Because of lateral inversion only, when you lift your right hand, it will be appearing like you are lifting your left hand. Okay, now let us take questions from exercise 7A. A ray is incident on a plane mirror. Its reflected ray is perpendicular to the incident ray. Find the angle of incidence. So here we have the plane mirror, M dash. This is your normal, OM. Okay, a ray is incident on a plane mirror. Okay, its reflected ray is perpendicular to the incident ray. If reflected ray is perpendicular to the incident ray, we know that the angle of incidence is always equal to angle of reflection. Okay, so what is given? Its reflected ray is perpendicular to the incident ray. So if you are having an incident ray, the angle between the incident ray and the reflected ray is 90 degree. Okay, so what is given? Its reflected ray is perpendicular to the incident ray. So angle of incidence plus angle of reflection is equal to 90 degree. Here we are given that the angle of incidence is equal to angle of reflection according to the first law of reflection. Okay, so we need to find the angle of incidence. In place of R, we can put I because they are equal. So I plus I is equal to 90 degree. 2 times I is equal to 90 degree, which means I is equal to 90 degree divided by 2, which is 45 degree. Angle of incidence is equal to 45 degrees. Okay, so this is the incident angle, which is 45 degree, and this is the reflected ray, OB, angle is equal to 45 degree. 45 plus 45, 90 degree, which means incident ray and the reflected ray are perpendicular to each other. That's all for today. In today's class, we have discussed about reflection of light, laws of reflection, and also the image formed in a plane mirror. We have also solved problems related to it. Hope you all enjoyed this session. I'll be back in the next session. Until then, stay tuned to Learnohub. Learnohub free hai, par best hai. Thank you.